right. So just kindly be informed that this call is being recorded, and once again, good evening, good afternoon, and thank you for joining us for yet another edition of our Python programming class. And quickly I would share my screen so we start in earnest. All right, so kindly confirm once you can see my screen. Can anyone help us confirm that my screen is visible? All right, I can see that confirmation. Okay, so in our last class we had an extensive discussion on the very basics of Python, the introduction to Python, right? We went through how to set up your device to start programming in Python, and we started from the basic concept of what is even programming and why Python, use cases for Python, installing Python and other and code editors such as VS Code and Jupyter, and then writing and running your first script or your first Python code, then the print function, comments, script files. Then I think we gave a stab at data types, and I am not sure we did much on variables, variable assignments and naming, among others, right? So in today's class we would have a quick revision of our previous class. Then we'll now delve into variables and then other operators, right? Then by the time we exhaust that, then we can move on to the next topic we have here. So for those who are joining us for the first time, you have not really missed much, since today is the second class we are having. This is our very second class on Python, and the previous class, everything we discussed are available on our YouTube channel. So if you are in our WhatsApp group, then you should have access to the links to the playlists, right? So that being said, we would move into the class proper. And then of course the first thing is to launch your Jupyter Notebook. So what you are seeing here is called Jupyter Notebook, and those in the last class can remember that this is kind of an interactive environment where you can write your code in Python. It's another form of it. It's like within this place, it's a browser-based code editor, not just code editor. It's a full package in terms of within here you can write code, you can run code, you can also debug and do other things, right? So we had a kind of an exhaustive exploration of this very tool, how to set it up and how to start working with it. We also have different features such as creating this cell below GB or OCA. There are many features we explored. Of course, you can also go to the exhaustive list of keyboard shortcuts. You can find them in this help section, which is show keyboard shortcuts, right? And then of course, before that, we also covered how to launch your Jupyter Notebook, which is either you launch it directly from Anaconda, right? From the Anaconda navigator. If you have Anaconda installed, right, you can just come and type Anaconda, and you would see this green circle, this green icon, which represents the logo of Anaconda, right? And from here you can launch it. Alternatively, you can also launch it from your PowerShell, or power prompt, command prompt rather. So, and that one is usually the faster alternative, right? So this is the folder from where I want to open my notebook, right? So I can just come to this folder and then Control A to highlight the entire link, then Control C to copy. Then I can come and press the Windows key, then start typing Anaconda. Then I will see this one, you can see different options. We have Anaconda prompt, Anaconda Navigator, Anaconda PowerShell prompt. So in our case, in this second instance, we want to open the Anaconda PowerShell prompt, and then we will now change. It opens up this, and it will now change to the folder. So you give it some time to fully open. So we will now change to the folder that contains the file we want to work on. So it might take some time to load. Let's give it like kind of yeah. So it has opened, right? So currently it's at the base directory, right? You can see users/user, right? So I want to move to the folder that contains, that's this very folder that contains these files, right? How can I do that? I can use this command, which is and then just to mention, if you are not used to working with your shell or power command prompt, you should not feel intimidated. I would have a class on how to navigate the command line, right? So what I want to do now is I want to set my working directory to this very folder that contains this file, this one that is currently open here, which you can see now. You can see that the name of the file is Python fundamentals data types, right? So I want to move my working directory to that folder, so I can just come here and type cd. Cd means change directory, short form for change directory. Then I type space, then I open quotation, then I'll paste the link to that folder which I copied. I don't know if I copied it correctly. Okay, yeah, this is the link to the folder. Yeah, I've pasted the full link, then close the quotation, then hit enter. So you can see now that I'm in this folder. What you see now confirms that I am in this folder, right? So for us to verify, let's list out all these files you see within this folder, right? So I'll just type ls, then hit enter, then it prints out for me the files in this folder. For example, we have the mode, we have the last write time, length and name, right? So we should focus on this name. For example, you will see here that we have a data types and structures.ipynb. So if I come back to this place, I would definitely see that type, data types and structures.ipynb. So I would scroll to the top for me to see that this is the file here, right? I can see this other one called doc.347. This one called 52. Right? So this is as a pretty fine version of it, right? But as a programmer, you want to work for this place because it uses none of this, and it flexibility to have it, right? Then you want to use a touch, right? So just confirm that the folder you work from, you can just type it down JUPYTR, then space boot, then enter. And it takes some time, like 2 minutes or so, depending on the state of your device. My state program. But what we're going to do is a touch done for you, which you now has you mentioned that what you use now is written one disk, right? So that's from the language, which I can it's not everything. Then with some functions here that you can click on to open a particular file you want to work with or work on, or to create a new file, upload, or whatever thing you want to do, right? So we'll give it some time to load. Just for demonstration purposes, because we've already opened it here. So let me confirm. So it might take some time to load because I have a lot of applications open on my device, right? But what you would see by the time it opens is exactly what you see here, right? That would bring to this place. And then from here, you can now open the very file you want to work on, which is in our case, this on Python fundamentals data types, right? So I've opened it here, and it launched on GitHub, right? So, and then we're now in this interface, right? So I'll just quickly close out the other one, since we really don't need that, just for demonstration. So it has no, we don't need that, so I'll just close it, right? So I've killed that now. The second as well have the one that powers the one we're seeing now. So this is a share, power prompt share, right? Powering this very one that is open. Then the second one that I just killed would have powered the second share, but we don't need that. So that opens for us, and then just for a quick recap, for those that were not here, this is a place where you can write your code. You can write executable code here, and it is interactive, meaning that when you write a code, right, you can get the response, the output immediately, right? And then you can also format your code. You can also write text, accompanying text, description. From here, you can create a polished notebook, which you can even publish, maybe a research outcome. It supports images, texts, and whatever you may want to view, right? So it makes it very interactive. And just to mention, it is also a place where you can write not just Python code, you can also write other codes in other programming languages. So you can write in R. In the last two classes on R, the facilitators took us through different ways you can launch R, right? And then I think the last one, we were working from the second that was Richard worked from Google Colab, right? Google Colab is just like an online version of what you are seeing here. In this case, this is running on my local computer, but in Google Colab, I am interacting with it remotely using a Google environment, right? So you could also write in Python or other programming languages such as R, right? So in this case, I'm running on Python. So that is what Jupyter Notebook does for you, and we will not dwell so much on this since we covered that extensively. If you are feeling lost, just hold on. You would definitely catch up, and you have the videos on YouTube to watch, right? You have the videos on YouTube to watch. So for today's class, we are going to quickly brush through data types. I think we covered that in the previous class, but we'll just quickly do that again. Then we now move on to variables. So we recall that data type is like, so before I proceed, I hope you all can hear me and see my screen. Someone should let me know of that. So let me just get your reaction to show that you can hear me and see my screen. I can see Peter unmuted. Peter, can you hear me?
Yes, I can hear you.
All right, thank you very much. So back to the demonstration, we mentioned that since in computer in general, all they know is zeros and ones. If you are from a technical field, maybe you studied computer science, electronic engineering, electrical engineering, you would already be familiar with this concept that what it understands is zeros and ones, and zeros can mean maybe a high or a low, maybe 5 volts 0 volts, 5 volts 0 volts kind of. So we are not going deep into that, but the whole concept here is that since it is only zeros and ones that the computer sees, how can it represent data in different formats? In this case, we have this text here displaying here. In other cases, if I scroll down here, I even have an image embedded somewhere here. You could see that this is an image, right? It could even be a music player. As you could see, my YouTube is open. You could also see that it could be this call we are on currently, right? I have a combination of different forms of data, like we have the video, we have the audio, we even have the text, a lot of things. So how does a computer understand exactly what is what? How does it distinguish between two different kinds of data, right? That is where data types come in, right? And the data type essentially is just a way to represent data, to distinguish it. I mean, to specify what kind of what type of information is stored in a particular variable. And the data type of the type of a particular data can inform a number of things you can do, right? In terms of the type of operation you can perform on that data, the kind of the ways they can be stored, and a lot of things. So just quickly, we covered the basic data types in Python, which are the integers represented in short as int, and then what they mean is whole numbers without decimal places. For example, 142 minus 7, just positive whole numbers without any dots, something something. And the broader class of it is numerical, right? So we also have float, which is represented as float. Float simply means numbers with decimal places or numbers with decimals. For example, we have 3.14 or minus 0.5, which is also a numerical. We have other types like strings, and a string simply means a sequence of characters such as letters or words, right? So it's represented as str for short. We have this hello, Hello, hello. We have 1, 2, 3 in quotation. Strings are non-numerical, and for example, this one in quotation is different from normal numerical one. That means in computer, if I have string as this 1, 2, 3, that it is not equal to 1, 2, 3, right? And we will be able to cover that, being that this one is a string, so the computer sees it as letters. Meanwhile, it understands this one to be numbers or a number, right? So that is one of the ways that the data type of a particular data can affect the way you can work with it. So in the first case, where I had quotation around the 1, 2, 3, I cannot start saying name. Okay, let me do that again. So in this case, I have let's say x equals 1, 2, 3. I cannot come and say x divided by 2. It will give me an error, right? Just take to soon throw up an error for me. And kind of my laptop is a bit slow today. Okay, yeah, this is an error saying unsupported operands, operand type 4, that is division, that this one is string, and then the operand, the type of operation I wanted to perform is one I can apply on a number, numerical, on an integer, right? But if I remove this quotation around it, it works. X equals x over 2 is equal to 61.5. So that shows that the type of data, the data type can influence the kind of operation you can perform on a particular data. We also have booleans, which are data types that can either be true or false. So they represent true or false, and values are used for logic and condition checks. In this case, capitalization is important, being that true is not the same as true. Neither is it the same as true, right? So we covered that extensively. In Python, you start with true, which is the first one is capitalized, followed by the other ones in small letter. In R, as we saw in the class of yesterday, we saw that you have to represent it as true, all in capital, or false, or T for true, or F for false, right? So these are the differences between the different programming languages. In something like JavaScript, you will see it as true, small letters, true, or something. I'm not really a Java programmer, but I guess that is what it will be, right? I think so. I may not be sure. So those are the different ways that the data type can influence the type of operation. And then we also have the non-type, which is kind of a special kind of data that represents the absence of a value or a null value. Example, none. Then there are many other ones which we'll eventually cover with time. So, and to know the type of data of a particular, the data type of a particular data, you use the type function, right? So in this case, I will go back to my example, x equal to 1, 2, 3. I think I have to zoom in. X equal to 1, 2, 3. Or let's say x1 is equal to 1, 2, 3. Then x2 equal to 1, 2, 3. So now let's see the difference. Print type. or let's just say print type of, that is type x1, then print type x2. So you will now see that for the first one, which is type x1, that is string, right? The second one, which is pointing at this and this are not same, right? Then now we saw that this one called type. You have the type of, right? You use type of instead of type. Those are just the difference between these different ones and them. You put them together, so you could compare and contrast, and then it could also be a faster way to learn, being that you are getting to see the differences between each of the two, right? So now let's move on to next thing. We had a kind of exhaustive class on this, right? So I will not go back to that now. You can check out the video on YouTube, right? So today let's delve into the next concept we will discuss, which is variables, right? So now, first of all, what is a variable? A variable is a name that refers to a value stored in memory. For example, just picture variable as a container, right? And a container usually contains an item of value, right? For example, for the ladies here and for the guys too, you have your cream. In the room, you could have a container, I mean different containers, one for certain kind of cream, another one could be for your hand sanitizer, another container could be holding your body spray, another container could be holding your powder, and so on and so forth, right? So the container is pointing to the main, like it contains or holds or stores something of value. So that is what it is in the basic form, right? In the most basic form. So in computer or in Python programming and in computer programming in general, you also have the similar concept, which is called variable, and then which is something that stores, or a name that refers to something stored in memory, or to a value stored in memory. So in this case now, I have name here to the left, and then I have Alice. Alice is the value I want to store, right? And name is the variable I store it. So that if I want to call this Alice, if I call mention name, right, it will come from Alice. So let's see that in action. So if I come down, or let's do text name, right? It's from Alice. It will come from me. It's returned, right? The age. Let's see if that works. It's text, right? Name and age, right? This Alice. Yes. I don't say print it, and I don't say Alice, but I mentioned the variable, which is the container that contains value called Alice, and the next one contains the text, right? That's the difference. So yeah, name is holding this string Alice, and age is an integer, and age is not a variable, holds the value initial check, right? Now to assign a variable, right? It takes two things to assign for a value and to assign a variable, right? The first thing, as I said, left here is something called a variable name, right? To the right as well, we have the value and the name stored. Then in between them, we have a quality sign or quality sign. But in programming, everything called assignment operator, right? Also, it's an assignment operator, right? So not entirely same. Use something to store in Python in a variable. Now, you always say that for those who have something like name, something like name. Then we have the left arrow, then dash, something like Alice. Alice. Alice, right? This is how you would have done it in R. But it's also the same syntax for R. What R that you use it, because this is for workout R. So in R, assignment operator could be equal to, or that's this one, or this one. But in Python, assignment operator is this one, which we normally call equality sign, right? I mean equal to. So just make sure you remember it. I think it's even pretty straightforward. So what that means is that To the left, we have the name of the variable. Then to the right, we have the value being stored. Then in between, we have equal to. And this is just a simple case of using a string. It could even be a dictionary. It could even be an entire audio file that you are storing in a variable called name, right? Or it could even be a whole Excel file that you loaded in Python that you are storing to a variable. So as we proceed in this class, we will see how powerful and how easy variable makes our lives as programmers. Now, let's look at how to assign. Okay, I think I just covered how we assign variables, explaining that in Python, variables are assigned using this operator called assignment operator, right? So in this case, we have x is equal to 5 and y is equal to x plus 2. So now let's print y and see. So what happened is that y is equal to x plus 2, but we've already told Python that x is 5. So wherever you reference x, Python returns for you 5. So what Python is seeing here is the value 5, not the x, and then adds it to these two, and then that prints for us this 7. So you see, that is how variable works, the basics of it. And then one thing to to take note of in Python, if you come from another background in programming, Python is dynamically typed, meaning that the type of data in some programming languages, let's say C++, right? Let's say C++, if you want to define a variable, for example, this x that we have now, you have to define it. You have to declare it that is, you declare it specifying the type of data it holds. So in this case, in this case, it would have been something like int x. Or something like this, you can just go straight and assign it int x equal to 30, or you just define it initially and close it like this. That is for another programming language, meaning that you are telling the interpreter that the data type that this value x is going to store is going to be an integer, right? But in Python, it is not like that. So each of them has their own benefits and their downsides. So in Python, which the type of the data is assigned dynamically, right? It means that the interpreter is able to figure out the type of data stored in it at the time of compiling it, right? So you don't need to define it, right? But it also means that it can waste a lot of memory, right? Unlike in the other case. So those may not be the things to bother you at this stage. Just know that they are dynamically typed, so you don't need to declare it beforehand. Now let's look at dynamic typing and the reassignments. I've just explained dynamic typing, which means that Python assigns or figures out the type of data stored in the variable. You don't need to specify it by yourself. So about reassignment means that you can reassign a variable to a value of a different type. That this makes Python flexible, but it also requires care when reusing variables. So what this means basically is that this x was initially, the value stored in this variable called x is 10, right? We have x equal to 10, right? So in this case, x is an integer, right? Then we have this one called the second x, which is 10, which is a string, right? So in this case, x is now a string. So if I print x now, what do you think would be the output? The output is going to be the second value, which is the string. Why is this so? It's so because you initially set x to 10. Then again, you came here and changed it to a different value. It's just like you bought a cream in a you just like you bought say Coca-Cola. Initially, I bought Coca-Cola, but eventually you don't want to use to something like liquid soap or whatever it is. So what you now saw in that container is no longer the salt here. It's now the latest one, which is now the string. You see that for us, right? That's like basic. I think someone is okay. So I hope you can still hear me and see my screen.
Yes, you can.
Alright, thank you so much. So the other thing we'll look at here is some rules you need to follow when you want to define the variable. When you want to define a variable in Python. So some rules you need to abide by other variables. And then these are even when you think they are not necessarily Python, right? Based on my convention and the local things. And it also what you keep note that. So it tells you that the name which is the one left right must be or underscore. That means the name of a variable must start with either A, B, C, D to whatever. It could be capital letter or small letter, or start with an underscore, right? Now there are times when you need an underscore. You would typically need an underscore when, for example, maybe the type of variable you want to, if the name of the variable is already a keyword in Python, right? For example, we have something like list. List is a keyword in Python. If you watch very carefully, when I finish typing out list, the color changed to green. So you have a list, I can list, I can list right? You know, keyword. I mean, example words in Python. We can underscore. It's just somehow, right? So it doesn't use underscore. Or if you just prefer other is like class example, we have class is a keyword. So only if that will be I just need for that. If I know about finding a variable, then it's like must start with or an underscore. Let's say my name, or let's say first student. So this is now if I start with something like first student, like first student or something like this, it runs into something multiply. So this basically you that you have a variable number. This one is 0, right? First one, second one, or say I something wrong. It's a variable here. So you have to look at about it means that if you are giving your variable a name, it should either be a letter starting it on underscore. Then the second one is that it can contain letters, numbers, and underscores. Now, this first rule does not mean you cannot have numbers in your variable. That it must only be letter. No, it only says that numbers must not start it, right? So I can change this thing to even if I have first, or let's say something like top three students equal to, let's say it's a list now. Let's say Joyce, the names I can remember. Let's say Peter, because I've called Peter today. Then let's say the third person, who would that be? Okay, let's say Eben. Right, so that works correctly, right? If I call this, for example, if I say print this, you see that it prints out for me Joyce, Peter, and Eben, for example. So that means number, we could have a number in between, we could have underscore, we could even have letters, only that number must not start it. So I can put underscore here to separate them, to make it more readable, and it still works, right? Now the third one is that they are case sensitive. Something like let's say, okay, let me create another cell here. case sensitive. So something like age equal to 3 is not the same as age equal to 3. Now let's see if I ask Python age equal to age, it gives me, sorry, no, this will not be the perfect example. It told me yes because I assigned the same value 3 to it, right? So what it means is that let's assume I did not declare this second age, for example. That means age, I think I gave a bad example in this case, so sorry about that. So if I have age equal to 3, for example, I can say, let's say print age. Print age. It printed age because I've already okay, let me use something else. Let's say let's say length is equal to 3. Now let's print length in small letter is the one I created. So if I run it, it gives me an error, right? So you could see now that, forget about the bad examples I gave. The concept here is that name length is not defined, right? But you can see length here that I just did. This one is all in small letter, whereas this one is in capital letter. And this one is in capital letter, right? So this is if I keep it at the back of your mind so that you don't go and start having a headache for trying a variable, calling a variable you not properly defined, or looking for a variable when you see it with a different case. Right? So that's it. And then let's look at the other thing to keep in mind. The other thing to keep in mind is that you cannot use reserved keywords in your variable name, or you can use them as variable name. For example, let me start with another one. This example. So you cannot say something like is equal to yes, something like this. It gives me an error. Is equal to yes. Is a reserved keyword in Python. Now there are a lot of them, and one way to find out is just come and search reserved keywords in Python. Just come here and search. Then it takes you to the official documentation. Okay, there are many different places you can see them. You have some credible websites. We have this Real Python. We have this Geeks for Geeks. We have many other places where you can see that list, right? Many places online. So let's check out this one, for example. I think I trust this Real Python. Let's see if it opens up. Okay, so there are a lot of them. So you could see them here. These are all reserved keywords: false, def, if, raise. You see the is we just used is one of them. So we have false, def, if, raise, none, del, import, return, true, elif, in, try, and, else, is, while, as, except, lambda, with, assert, finally, non-local, yield, break, for, not, class, from, or, continue, global, pass. So these are reserved keywords in Python. So to find it, you don't even without searching. Let's try this. Help in brackets keywords. Let's see if it will print it out for us. So you can see that we have that same list here, right? It says here is a list of the Python keywords. Enter any keyword to get more help. All right, so we've seen it already. Yield, right? So with these reserved keywords, you can't use them as a variable name, right? Then the other thing that we've covered this for, that it must start with a letter, must contain letters, numbers, and underscores, case sensitive, and cannot use reserved keywords. Now the other thing to check out here is I think we have another example to look at. For example, okay, we've done this one, which is first number, that gave us an error. Then something else like a class is equal to math. I think we've demonstrated this one. This will give us an error because it uses number. It started with a number. Now in this case, class is equal to math. This will give us an error. Why? Because class is one of those reserved keywords. You can see class here. Now, what else? We will need to move on to the next thing to talk about here, which is naming conventions in Python. Naming conventions in Python can be very important because it helps you, not just you, but it helps mostly with when you are working with people. Like it just like it makes your code Pythonic. A Pythonic code is a code that abides by certain guidelines in Python. You see that when you see a code written in Python, you know that it will be easy to recognize that these are Python codes, right? This is a Python code or something. If you see another code written in another programming language, you will notice that it's actually different, even by mere merely looking at it. These are different conventions. Now, when I affects a variable name, the upper ones, different can clear variable or can find variable. The first case, that one case, like your case, and most. Now, just to be clear, now you have to work with. Try your best to stick to this something case. That's the convention mostly commonly used in naming variables functions in Python, right? So, if you are coding in other ways, such as I guess, let me use Java, you can't be very just scripting programs and other languages. Now, look at the example says now that all class and words are separated underscores. So it's the common one in Python, both for the functions. So in this case, length of rectangle. It's length of rectangle. So you could see that everything is lumped up. Like it will be very hard for me to read this. So I will now put this underscore to separate them, right? Put underscore to separate words. Length of rectangle. So everything here is in lowercase, everything is lowercase, and then words are separated using underscores. Now I also have width of rectangle, which is 150 assigned. So the next thing is now area of rectangle, which is now product of length and width, right? Now let's print out the product, the area of rectangle. You see that it runs. Now the second thing we look at is camel case, and it's also known as Pascal case. So in this case, each word starts with a capital letter, and then in this case, sorry, the first word first word starts with a capital letter, and there are no underscores, right? You might consider using this one when you want to name a class. We've not gotten to object-oriented programming where we will define classes and all that, but just note that we have camel case. So it's when you want to declare a class or define a class that you use camel case. So then here the first word starts with a capital letter. Come on, first word starts with a small letter, rather, please pardon that. First word starts with a small letter, then and subsequent words are in or start with capital. Now there are no underscores. So you typically use them for class names, right? So what this means is that we are still going to see it in this example here. We'll see that length of rectangle, just similar to what we have here. The first letter of the first word here, we have three words here: length, then we have of, then rectangle, right? Just to give this variable a name. So the first one starts with a letter, small letter. Then second one starts with capital letter. Third word, the first letter of the third word as well starts with a capital letter. So length of rectangle is 300. Same applies to width of rectangle is 150. Then area of rectangle. You know how the camera is, right? From back on the rear, right? It's like a slow heat graduated flowing in some sense. So just if one of let's look at a camel picture of a camel. Okay, so you can see from the back, so that this is just look at this on the first part here is like small letter, you have capital letter starting the next way, you have the capital letter starting the next way, like that's what makes it camel casing, right? But for snake casing, it's case it's different. So those are just conventions, not that your code would not run if you don't follow them, but it makes your code more readable and then more Pythonic. So if I run this one, even though it's in Python, it still prints out for me the same 45,000, which is the area, right? And then the third one is the letters are uppercase and words are secret bytes. So here we use them for constants. For example, constant just means some variable whose values are not set to change, such as pi, for example, it means approximately 3.14, and so right? Another form of a variable, a constant, can imagine, is say gravity 9.8 million meters square. Other values like the number of hours a day, do not change the where you are on X, right? 24 is 24. So you know that. So in order to define system variables as constants, and when you want to them, those programming results will change. Since you can assign another value to keep to find a constant, expect change people that you are collaborating with. Don't want this way. This variable to change, right? So you can use a maximum limit. Use that in a category called you can use it case, right? So max limit, max separate using underscore limit, like all high, you know, around 64 positions. So you have similar variables, less more times. Very referring is clear. So that means all these things is that you want to be your variable name. You name that can quickly recognize in the point in any time, right? If this is a program to right function, but I want to create the rectangle, right? And I can assign x and like I can see this like something like x equals 300, y equals, or some, let's say, let's use L, nice for length, then width equals let's say 150, then A for area, A equals L times W, then print A. So it still prints for me 45,000. So that shows that everything we've been discussing will not necessarily break your code, but there are conventions that would help you write cleaner code, right? But there are times when you don't necessarily need to specify the full name of a variable, such as maybe when you are using it within a loop. We've not discussed loops and conditionals yet, but when that time comes, you see that there are times when you just need to be brief as possible, or you just want to perform some form of iteration. It's not like the variable name is really going to be reused for long and all that. So that is one exception to this. So at this point we are midway into the program, the session, and I would like to take a short break to get your questions, or if you have maybe anything, maybe you have a question you want to ask, you can chip that in based on what we've been discussing all this while. So you can feel free to unmute yourself, ask your question, and then whatever thing you want to chip in before we move. So just consider this as an interlude. Is anyone that wants to say something? Hello? Or should we move on?
Can you hear me?
Yes, I can.
Okay, yeah, the Python keywords you mentioned, you said that you can still use the underscore to start it. Does it apply to that as well? Can we use underscore to start a variable name that is a keyword in the Python? I don't know if you understand what I'm saying.
Can you maybe, yes, I can, I think I heard you. If now you can only use underscores to start a variable name if the variable name happens to be a kind of a built-in kind of a keyword, a reserved keyword, right?
Yes.
Yes, you would want to do that, because if you use the reserved keyword, you might end up overwriting some useful functions within Python that would now result in a lot of errors for you, which you may not even know, right, subsequently in your code, right? Something like list, like I mentioned, is a keyword, right? Something like list is a keyword. So if you don't use underscore, you are going to overwrite that list, and it's going to give you errors maybe the next time you want to work with maybe that function called list. So that's one of the reasons you need to do that. Did I answer your question?
Yes, thank you.
Alright. Any other person? Muli, Michael, Marilyn. Who else has a question?
Hello?
Yes. Eben, can hear you.
Yes. Good evening. Sorry. Can you repeat the answer you gave to the last question? Sorry. I just need to tell.
Okay, he asked if, I was explaining that you should start your Python, your variable name with either an underscore or a letter. So he was asking to confirm in what case or what scenario does that apply. So I now mentioned that typically you should start your variable name using a letter. But there are some times that maybe you are working on a record involving students. Maybe for each student, you want to capture data such as their name, their age, their class, right? Their grade, right? Now, you will notice that, let's say CGPA. You will notice that certain things here, for example, class. If I zoom in, you notice that class is a keyword. We just printed the list of keywords we have in Python, and class happens to be one of them, right? As you can see here, this is class, right? This is class. So you can't just come and call another variable class. It will not work. But you need this class because it's part of the records you want to hold. So you can work around it by maybe just modifying it to something like class of students, right? Or if you must explicitly use class, then you need to put an underscore before it, class, or even after it. Maybe something like this. You notice that once I add this underscore, it changes back to normal black, meaning it's a normal variable, right? So that's one situation you would need to start a variable using an underscore when it coincides with a keyword that you are not allowed to use or change in Python.
Thank you, Samuel.
All right, thank you. So I think we need to proceed, right? And then, so now the next thing we need to talk about in this variable is a scope of variable, right? Scope of variable is only talking about where within your code, like it's just like the coverage area of a particular variable, right? Coverage in the sense that the position where you define the particular variable can in fact affect your ability to use it. Like if you define the variable in a particular location, right? Will you be able to call it in another location? For example, we all know that Python is number one, not just case sensitive, but it's formatted in such a way that it comes in hierarchies. Like here now, everything you are seeing here. Let me just put something like, let me press L and then see if the line of code. It's not working here. Okay, so what I was trying to say is that in this line block code block, right? You see that this one, the distance, this is the start of the code, right? From here to the left, right? I can't type in. There's no space from this very place where my cursor is to the left. There's no other space where I can type anything. So I type from here. But you could see that print here jumped some space, like about 4 spaces, right? So the indentation affects a lot of things in Python, right? It's a very important thing to take note of. Now, what we are saying here by the scope of a variable is that position where you call a particular variable can affect your ability to use it or call it in order to use it in another in your code. Now, that says name is equal to Bob, right? So name was defined, the variable name was created from this edge, right? Now, if I come here and I create a function called greet, I can say print hello plus name, right? Meaning to print hello Bob, right? So this is an example of a global variable, right? Name is a global variable, meaning that it is defined outside functions are set throughout the script. So there is no way within code, this is the whole outline code, and there are 25 or 200 functions within here. There's no way I cannot call this variable name, even if it's in a function inside something, if it's in a function, right? But with a function, a variable is a global variable. It means that it's defined inside it and only available within the function. Right? So in this second example, this function called greet, function we have before, which okay, for example, what it does is we have this variable called username, and the username is called a block name. So I want to print hello, right? So I will print, if I print username hello, I will be to return this value. But that's because I call this print function is no longer side of this function clear. Right? If I click here, you see that I would expect the function to continue writing my line of code using the same indentation you could see from here to here. From the moment I defined, I started this def slash space greet, then this colon, right? It started applying indentation to it, right? So from here to here, I have 4 spaces to the left. From here to here, we have 4 spaces to the left. So it's like a hierarchy. So if I come here again and I click enter, it expects me to continue defining the function. Meanwhile, I have finished defining my function. So what I now did was, at the end, I now broke out of the function. So I now pressed delete press the space bar to start another line of code. You can see that this print username started on the same line with this one called def, which is the function we find the function. So in terms of hierarchy, this is like at the start. Then everything within here is inside of this one, right? So this one I highlighted is at the same level with this one, right? So that means I defined this variable called username inside of this one, and for that reason it is not visible to the print function here. So let me run this kind of campaign. It throws up an error, meaning name username defined. Username defined here. So it's only this username that we find inside of this function called, right? A local variable. Can't outside of function. Now let's modify this code. Let me comment out this one. And let me go inside this function and say, let's run the same code. Print username. Print username. So I would need to call this function outside for us to say it will be able to access the username. So I can now say let's say let me just call the function. So it says hello Chinedu, right? Okay, now what I wanted to do is this. It prints out Chinedu for me. That means by the fact that I created this function, this variable username inside of a function, I can only use it within the function. I cannot come outside of the function and call it. Python will not be able to see it, right? So that is what a local variable and a global variable is all about. I hope this was clear enough. Was this clear before I proceed? Hello? Was this clear enough? Okay. Alright, so let me check. Okay, so we're back to... Okay, someone's hand is up. Also, okay, reaction. So if you have any question, you can always draw my attention before we go too far. So now back to the code. You could see that this function, this variable called username, is not visible outside of this function, right? But you can call it within this function, and you can still use it within this function. But this one called here, this one called Bob, this one called name, right? You can access it anywhere within the script because it's a global variable. Now, there's a way we can modify global variables. For example, you can modify a global variable inside of a function using a keyword called global. And what does that do? Now, we have a global variable called count and assign the value of 0. So that makes it a global variable. We called it at the topmost, not just topmost, but there is no at the topmost level, which is from the left. Just when you started your script, you didn't put any indentation like this for that. So we just defined it and assigned it a value of 0. Now we now want to create a function, and then this function is supposed to modify this variable inside. It's supposed to modify this variable called count, right? But you can't directly do that in the sense that even if you modify it within this function, right? When you come out of this function, it will not affect this one here, right? It will not affect this one here. So let's say the first function, the function name, let me comment this out. It's called increment. And what it does is it simply adds 1 to this 0. That means it should change it from 0 to 1, right? So when I call the function, let me comment this one out. When I call the function, what will it do for me? It says unbound local variable cannot access local variable count where it is not associated with a value, right? So this function here, right, what this error is telling us is that it cannot access, it's not like let me look for a more friendly way to put it. It can be kind of tricky, being that you can still see this variable called count here, right? But you want it to modify you want this function to modify this variable called count, but it does not have the power to do that, since this one is more powerful. This one is at a higher state of power than what is inside this function, so it cannot directly modify this one, right? So if I come back here and uncomment this one out, uncomment this one, I can still get my count back, right? My count still remains 0, so it was not able to modify it. But if I change this one back, if I call this keyword called global, then count, it means I want it to go back to the global level, no longer local level. Like within here is local level, but I want it to go back to the global level where a variable count was defined, right? Go to the higher hierarchy where the variable count was defined. That is the count I want to refer to, right? So now I can now say global count. So I now apply the modification, which is to do it to +1. So then what happens is that when I call it, it now returns for me the incremented value, right? When I call it, it now returns for me the incremented value. So that means, as you can see here now, right, I have created this function and I have told it that the count go back to the global hierarchy whereby a variable count was initially defined, and then pick that value, whatever value was there, add 1 to it, right? Then I now came here to call the function. Like this line is just like to execute the function, right? Then I will now want to print count, right? Printing count would now, instead of printing 0 for me, it will now end up printing 1 for me. So that's how to modify a global variable within a function or somewhere else, right? So this count is no longer count, it's no longer 0, it's now 1. So that's one way to modify, right? Now another thing we look at is constants. Okay, I've already mentioned that constants don't have true, Python doesn't have true constants, but naming conventions are used to indicate that a value shouldn't change. So this should be defined at the top of your file, right? Okay, you could see now we have pi is 3.14159 and so on. Gravity is 9.8 in Newton. Okay, here you can just specify the units. There's I think Newton meter. Oh, is it Newton meter? What was the formula again? Oh God, I was a good student, so pardon me for that. Whatever the case may be, that's the unit. Like this is a constant, it's not expected to change, right? So that's how you define this thing. Now another thing is mutable versus immutable types for a variable. Is anyone trying to say something?
Okay. Yes, I'm trying to ask, the gravity, those constants, is it that once you put it there, the Python, it is stored in Python, it brings out the value, or you just have to put it by yourself?
Okay.
Like, let's say you're using a calculator, if you put pi, it will give you the value. Is it the same here, or you are the one putting in both the variable and the values?
Okay, in this case, you are the one putting in both the variable and the values, unless you are using certain libraries. Like we have other libraries like math, right? That already has those things coded inside of them, right? Something like a E. Let me say something like E now, for example. 10 is something like 10E. You can see that 10E 3 means 10 times 10 is to the power 3, right? So this E, for example, is already inbuilt. The value of E is already inbuilt in Python. You get? But that's not the case here, right? That's not the case here. So in our own case, we have to define it and assign it that value. Unless you are using a library that already has those things described for you, that's when use of library comes in, so that like certain libraries will allow you to just call values like E and then maybe pi, whatever it may be, and then so that's it. But in this case, we just defined it by ourselves. And I would like to mention like that our class might end by, let's see if we can take it to 9 p.m. So another thing we'd like to explain here is mutable versus immutable types. No, we are still talking about variables. Mutable types means that some variables can point to values that we can change, and immutable types are values that you cannot change directly. In terms of being able to change a value means maybe assigning an extra character to that value or whatever. Let's look at it. There are some immutable values such as int, float, string, tuple, and the rest. Then we have the mutable ones such as list, dictionary, set, and the rest. So let's look at mutable. Mutable in this case means that I have this variable called x, which is containing values from 1 to 3, right? If, for example, let me, instead of x, let me give it the name of student IDs. Student IDs. We have, or let's call it defaulters. Defaulters. Maybe you are the class rep and you've been instructed to write out the names of the reg numbers of students that made noise in class. So you are just storing their IDs, and at the beginning